Today's e-learning lesson is over solving quadratic equations by completing the square. This piggybacks on the lesson we had last Friday. If you were absent, please refer to the PowerPoint and notes that can be found on Canvas. All right, we are going to go through 4 examples. Please watch all 4 examples because they gradually get more involved, and the last one is the hardest one. So, in our first example, we have x squared plus 4x minus 12 equals 0. Our equation is in standard form, but to solve our equation by completing the square, we need to get the constant term on the opposite side. So we are going to add 12 to both sides of this equation, leaving space to find the value that completes the square. And you can see up on the top right in silver is how we go about finding the value of c that completes the square. What we do is we take the value of b in the equation, which in this case would be 4. We divide it by 2, and we square the result. 4 divided by 2 is 2, and 2 squared is 4. So the value that completes the square here is 4. And if we're adding 4 on the left-hand side, we need to add 4 on the right-hand side. Of course, now the left-hand side is a perfect square trinomial, meaning if you factor it, it factors into 2 identical factors, which in this case are both x plus 2, which we can write as the quantity x plus 2 squared. The right side, of course, would become 16, and now we can use square roots to simplify both sides. When we take the square root of both sides, the left side becomes x plus 2, and the right side becomes plus or minus 4. So now we're going to get x by itself by subtracting 2 from both sides. Normally we put that value in front of the plus or minus, and because we have integers, we can separate this, and we're going to take negative 2 plus 4 as one solution, which of course would give us x equals 2, or x equals negative 2 minus 4, which gives us x equals negative 6. You might recognize that this is something that we could have factored. This is just another way of solving the quadratic. If we were factoring it, we would do this and find 2 numbers whose product is 12 and difference is 4, which are 6 and 2, and it's going to have to be plus 6 minus 2, and notice that produces the exact same solutions. It's just a different method. And sometimes it's a great method to use, and other times maybe there are other methods that are more efficient. In this case, factoring would be much quicker. However, we're focused on completing the square, so all of the problems you're going to be solving will be solved by completing the square. All right, moving down to our second example. Same process. We have our equation x squared plus 10x minus 3 equals 0. It is in standard form. We need to add 3 to both sides to get the constant term on the other side so that we're ready to complete the square. So we are going to take the value of b, which is 10, divide it by 2, which that would be 5, and square that result, which is 25. So we're going to add 25 to both sides. We now have created a perfect square trinomial on the left, which factors into 2 identical factors of x plus 5, which we write as the square of the quantity x plus 5. That will equal 28 on the right. And now we can take the square root of both sides, and that results in giving us x plus 5 on the left And on the right, it will be plus or minus. And the square root of 28 is going to simplify to become 2 times the square root of 7. You should recognize there is a perfect square of 4 in 28 with a leftover factor of 7. And that's how we get 2 times the square root of 7. Then we're going to subtract 5 from both sides, and that gives us negative 5 plus or minus 2 times the square root of 7. We should recognize that really means x equals negative 5 plus 2 times the square root of 7, or negative 5 minus 2 times the square root of 7. I don't make you rewrite it like that, but I require that you recognize that if you were asked to separate the solutions or approximate them. Moving down to example 3. This time we have 3x squared minus 6x plus 12 equals 0. And the first thing that we notice is a is not 1. Before we can solve our equation by completing the square, we need to get a to be 1 by dividing both sides of this equation by 3. When we do that, that gives us x squared minus 2x plus 4 equals 0. At this point, we want to subtract 4 from both sides. And now we can find the value that completes the square. B, of course, is negative 2. Divided by 2 would be negative 1. And when we square negative 1, that is positive 1. So we want to add 1 to both sides. The left side in factored form becomes the quantity x minus 1 squared. The right side becomes negative 3. This time when we go to take the square root of both sides, we find that the left side is x minus 1, but on the right side, we're trying to take the square root of a negative, which means we have a factor of I in there, and 3, of course, is prime, so that becomes I times the square root of 3. And then to finish solving, we add 1 to both sides. Again, 2 solutions are implied here. You are allowed to leave your answer like this, but it does mean your solutions are x equals 1 plus I times the square root of 3, or 1 minus I times the square root of 3. Last example, we save the fun till the end. And in this case, like the last one, a is not 1, so we're going to have to divide the equation by 2 before we can complete the square. When we do that, that gives us x squared minus, we're not going to go to a decimal form. We're going to leave it as a fraction, but we get fractions for everything. And when we have a fraction with completing the square or an odd value for b, that's when this process is not quite as fun, as we're going to see here shortly. So what I'm going to do is I am going to subtract 3 halves from both sides, and now I want to find the value that completes the square, and I'm going to go up here. So we take the value of b, negative 5 halves. Remember, we have to divide this by 2 and then square the result. Of course, here you might forget, since the coefficient is a fraction, to divide it by 2. But remember, dividing by 2 is really multiplying by the reciprocal, or 1/2. And that gives us negative 5/4, which, when we square it, becomes 25 over 16. So we get to add 25 over 16 to both sides. And now when we rewrite it, this is where leaving it as a fraction is great, because that becomes 5 over 4. Remember, the square root of the x squared here and the 25/16, or half of b, same thing, and then the middle term sign there will help you. And then on the right side, we are going to need to get a common denominator, which will be, oops, not 8, but 16. We've got to multiply by 8, which means that's really negative 24. So when we add, that becomes 1/16. So now we need to take the square root of both sides. And what results is the quantity x minus 5/4 on the left and plus or minus 1/4 on the right. If we add 5/4 to both sides, that gives us 5/4 plus or minus 1/4. And if we separate, 5/4 plus 1/4 is 6/4, which we can reduce to 3/2. Or on the right, 5/4 minus 1/4 is 4/4, which means x equals 1. Excuse me. Now, I want to show you that was a bunch of work. It's harder when b is not even or b is a fraction like this. And so I do want to remind you that's solving this quadratic equation by completing the square. But what happens if we had just tried to factor here? We'd have 2x and x. We need to put 3 and 1 in so that the sum is 5. Now, it's really easy to make a mistake here because you might say, oh, 3 and 1, 6x, 1x, but those don't have a sum of 5. We need a sum of 5. So what that means is that's not the right order, and we should look at changing that and putting the 3 here and the 1 here. Now our outside product's 2x and our inside is 3x, and that has a sum of 5, which is 5x, which is what we want. We've got to get our signs to both be minus so that the middle term is negative 5x. Now, what you see resulting is the exact same answers of 3/2 or 1. And look how much less work is involved when we solve this equation by factoring. Completing the square is a great method when b is even, like in number 1, b is 4, or 2, it is 10. In 3, when we divide everything by 3, b is still even. It's 2, negative 2. But then in 4, well, it was odd to start with, but you had to divide by 2, which gave us a fraction. It's just not a user-friendly method, but we get to practice it. And I will at least give you one that's a little more challenging in the homework, where you have to try and get through the process. The final result's the same. And in the end, after we've learned all the methods, you'll get to have some choice in which method to use. So your assignment right here is page 260 and 262. The problems listed there, 5, 13, I think they're both word problems, then 30, 32, 34, 35, 37, 40, 48, and then 67 to 70 all are some review problems. We will go over this when we return on block day. I will actually post the answers to Friday's assignment as well as this assignment because we want to use simplified radical form. Leave answers in exact form. Do not use decimal approximations. And I know the book has decimal answers, but that's more work than you need to do. And so leave them in a simplified form. If it's a radical, like we did above here, notice I never went to the decimal approximations here. I just left them with simplified radicals. All right, hope that helps you. Have a great day. We'll see you tomorrow or Wednesday.